Okay, so in this video we're going to review two ways to get non-probability samples, or in other words, two ways to get a biased sample reviewed in your textbook. Just as a reminder, when you have a non-probability approach, you have a non-representative sample, meaning your sample, the people you recruited for your study, don't represent the population of interest. So let's say I was interested in seeing where Californians stood in terms of gun ownership. Now, given that California tends to be a more liberal state, still, I want to make sure I understand where people stand. I want to see the percentages. Let's say this was my sample. Well, not my sample, I was sampling from this situation. Would I get accurate information or representative information of all of California if I sampled here? So in this situation, no, right? Because if you look closely, you see some Obama-Biden shirts. You see that they're actually at a Democratic convention. So you're not going to get a full representation of how people in California feel about this specific law. So that would be a non-probability sample. The sample we have, the people we recruited, don't represent the population of interest. So actually I already went over this example. Let me know if you have questions about this example. And just as a reminder, yes, it's confusing, right? Because you're going to hear me go back between representative sampling, probability sampling, unbiased sampling. I use less, but your textbook uses that word or that term throughout. So just keep in mind that these terms are referring to the same thing. Probability sample is the same thing as an unbiased sample because there's no bias in how you recruited participants. And it's the same thing as a representative sample because it's representative of the population. And non-probability sample is the same thing as a biased sample because if every person doesn't have the equal probability of being chosen, then that's biased. And because it's biased, it's not representative of the population. So remember that. We have these similar terms, or not similar terms, we have different terms referring to the same thing. You need to know this. Make sure you review this. It is confusing, I admit that. Sorry about it, but you'll hear these terms being used interchangeably, not just in this textbook, but in the field. So here you have another review of how they match up. In table 7.3 in your textbook, you can go ahead and review this. It'll help you remember. Okay, so there are several ways to get a bias sample. Two that we focus on in this book is convenience sampling and self-selection. Okay, so let's go over what that means. So let's go over this example that demonstrates how having a convenience sample might lead to faulty data. So I'm actually going to go from right to left because that's how this makes the most sense to me. But notice that you have on the columns three different groups of people. On the most right, you have people who have no phone at all at home. In the middle column, you have people who only have wireless. They only have a cell phone at home. And on the left, you have people who have only a landline or have a landline plus cell phone, right? So these are the different groups we're looking at, and we're looking at these three health indicators. Current smoking, or currently they're a smoker. They had a heavy drinking day in the last year, and also have they had an influenza shot, right? So the flu shot. Now, when you look at the most right, no phones at the household, so probably rural areas of America, of the US, I should say, you see that for current smoker, it's 20.8%. 20%, that's pretty high. When you look at wireless only, you have 18.8%. So you see a small shift, but you see a percentage shift when you include people who have no cell phones at home at all. But then when you look at the first situation, people who have landline only. I'm not sure why they decided to combine it this way, but landline only or landline and wireless. So pretty much they're looking at people who have landlines at home, meaning a phone that's connected to the wall. Now, I probably actually should have gone from left to right, right? So when you only look at people who have a wired phone at home, it looks pretty low. You add people with cell phones, it goes up. You add people who have no cell phones at all, then it goes up to 28%. You see that these numbers change based on who you're sampling. So if you're excluding people who are only accessible through their cell phone when you're calling participants, or if you're excluding people that you can't access via phone, then your data is going to look like pretty good. Well, only 11.5% of people are smoking. But when you look at these different groups, you see those numbers change. Now, if you look at the last one, who received the flu shot, if you only called people who had a landline, well, it looks pretty good, 50% of people, right? But then, okay, let's include people who are wireless. For people who only have wireless, that number dips, 33.9%. People who only have cell phones, that goes down. People who have no phone at all, they're in the middle. This shows you how a convenience sample might lead to faulty data. So this would be a convenience sample because you're only calling people with a landline. Those are the easiest people to get to, and maybe you include people who have a cell phone, and they're easy to get to because they have phones. The people that are hard to get to are the people that don't have any connection via phone. They have no cell phone, they have no landline. So you have to go out there and have them do the survey by hand or in some other way, right? So if you exclude these people that are hard to get to, you're going to get faulty data. If I only sample my students in my class and I want to generalize to all CSUN students, I'm going to have faulty data and I will not be able to generalize. So the other issue is self-selection. Now, self-selection means that rather than you randomly recruiting participants, people are self-selecting into your study. They're choosing to participate, right? So let's look at this study, right? There's an online poll. The online poll asked, was your child an early reader? So the options were yes before age 5, and now we have 27%. Yes before age 4, we have 28% there. Yes before age 3, 32%. That's amazing. No, but learned quickly in school. And then finally, no, and didn't seem to learn any faster than other kids. Now, first of all, think about who would choose that last option. Who wants to say that about their kid? Imagine coming across the survey and your child learned to read at 5. That's typical, that's normal, that's fine, right? But then you see these other options. Before age 5, before age 4, before age 3. Now, if you see your child as learning to read at an average age, are you going to want to fill out the survey? You probably won't want to fill this out. Think about who would want to fill this out. Parents who want to brag, parents who want to show my kid learned to read really early, right? So if this is the data you had, because people chose to participate, they self-selected, right? So you're getting the braggy parents, which are a lot of parents. Then does this data reflect the population of interest? Or in other words, is this accurately reflecting when all children tend to learn to read? At what age? No, because we have bias in the data, we have self-selection, we have parents who are very proud, want to brag, whose children learn to read at a very early age, end up taking the survey. Most likely that's what happened in this situation. Now, to give you another example about how self-selection might influence data, give me a second. There's an airplane passing by. Okay, so here's another example for self-selection. In this study, I have a new therapy, and I want to compare it to traditional therapy. And in this therapy, I want to help reduce depressive symptoms in patients. So this would be a treatment for people with depression. And we have a new therapy that I've developed. And this new therapy includes 1 hour workshops Monday through Friday, so 1 whole hour, meeting in groups 2 hours a day, homework worksheets, reading 2 books a week, and weekly check-in with a therapist. Okay, and we have another condition in the study that's just traditional therapy, where you have a weekly check-in with a therapist. Now imagine I'm paying you to do this. So you're participating because you're getting paid. And I let you choose which situation you want to be in. Well, you're likely to choose a traditional therapy because you're getting paid the same amount for less work. But let's put money aside. It's not just about pay, let's think about motivation. Now think about people willing to do the new therapy. Think about how motivated you have to be to decide to do this versus traditional therapy. Now, if that happens, we might result in another type of bias. Not so much in terms of how we sampled, but in terms of who we're getting in the new therapy. We're likely to get the people who are less depressed, who are more motivated because they're willing to do all this activity. When we think about depression, we think about the person who has a hard time even getting out of bed. So those who are willing to do the new therapy might have already been improving or lower in terms of their depressive symptoms than people in traditional therapy. So that's 2 ways how self-selection might end up biasing your data, but do focus on this approach where having people self-select might present you with data that is biased, that does not represent the population of interest, because you have the people who are more motivated to participate in your study, and you have a certain type of person that's willing to participate in your study.